Hello, 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 and thank you for listening to Mr. Laxton's video about these 9.5 notes. Today we're looking at adding, subtracting, and looking at some complex numbers here. So my essential question for today is how do I add and subtract rational expressions? All right, so we're going to look at adding and subtracting these rational expressions. We've looked in the last couple days, we looked at multiplying and dividing rational expressions. That's great. Okay, if you remember multiplying rational expressions, we just multiplied straight across. Dividing rational expressions, that's when we keep, switch, flip. All right, now there's a little bit difference for adding and subtracting. So the main thing here for adding and subtracting that I want you to know, I want you to highlight is this common denominator. We have to make sure if we're going to add two fractions, we need a common denominator. So if I write kind of just an example over here to the side, I have 1/3 plus 3/4. Can I add these two fractions together right away? And the answer is no, because that 3 and that 4 are not common denominators. So we need to find the same thing here when we're going through and adding these rational expressions. So if I look at this first example, I have x minus 4 and x minus 4. So you have to ask yourself, are those common denominators? And you say, hey, sure, yeah, they are. So we can actually just take what's on the top and we can add those guys together. So I can take 3x plus 6, and I can't combine those guys, they're not like terms, so I just have 3x plus 6 over x minus 4, and that is my final answer for example number 1. So if you have common denominators, you can just add the tops. Alright, so if we look at the kind of the example here, if we do not have common denominators, we must make one. All right, so think about how we did this. Okay, so if we have 1/3 plus 2/5, we have to ask myself, what's the least common denominator? So I know that the least common denominator between 3 and 5 is 15, because I'm going to take that 3, I'm going to multiply it by 5, I'm going to take the 5, I'm going to multiply it by 3. So whatever I do to the top, I must do to the bottom. Same thing here. So this is going to be 5 over 15 plus 6 over 15. All right, so now if I go through these guys and add them all together, I get 11 on the top and 15 on the bottom. All right, so get those common denominators, then you can add them together. All right, so to find a common denominator with rational expressions, you need to factor here first. That's going to be key. And then decide what the common denominator will be. Okay, so if I look at example number 2 here, I look at these denominators, I can't factor that 3x squared at all. But I can factor this 6x cubed plus 3x squared. And I can factor that by taking a 3x squared out of both those guys. So if I take a 3x squared out of 6x cubed, I'm going to end up with 2x and plus 1. All right, so I factored that guy out. Now I have to look, what's going to be my least common denominator? So I have to tell myself, hey, I have 3x squared, that's in both of them. All right, but this one over here just needs that 2x plus 1. So I'm going to multiply that by there, and I'm going to multiply it by that top, that 2x plus 1. All right, so if I multiply that top by 2x plus 1, if I sprinkle that 4 onto both those parts, I'm going to get 8x plus 4. And now over, and then now my common denominator is going to be that 3x squared and 2x plus 1. That's what I made for my common denominator. And now I'm going to add it, and then this whole thing over here can just stay the same because I didn't need to multiply that by anything because that is my common denominator. So I'm going to add that with x and 3x squared and 2x plus 1. All right, so now if I look, now that I have these common denominators, now I can go through and add. So I look, I have 8x plus 1x. So if I look there, 8x plus 1x is going to be 9x plus 4 over 3x squared, that common denominator, which is 2x plus 1. So that right there is my final answer, folks. So I got the common denominators here, and I multiplied it by the top and the bottom, and then I added those tops once I got the common denominators. All right, moving on to number 3 here. If I look at those denominators, I can factor that guy. So I can factor this guy on the bottom, that 9 goes on the top, that 6 goes on the bottom. So if I look here, 3 and 3, multiply to make 9 and add to 6. So I'm going to make this an x plus 3 and x plus 3. And then now you can notice here that this is DOS, difference of squares. So this one on the right here is going to be x plus 3 and x minus 3. So that's what we've been talking about in the last few days, recognizing that difference of squares, knowing what that is. Alright, so now I have to look for my common denominator because I can see that both of them have this x plus 3, so I don't have to worry about that. But I can see that this one has an x plus 3, so I'm going to need to multiply x plus 3 over here. And then I'm going to need to multiply the x minus 3 over here because that's right here. So my common denominator is going to be this whole thing right here, this x minus 3, x plus 3, x plus 3. So that gets a little bit long here at some point. All right, so now if I look, I have to multiply everything on the top by x minus 3, and I have to multiply everything on the top of this one by x plus 3. So what I multiplied by on the bottom to get those common denominators. So here, for this one on the left, I have to FOIL this guy, all right? I actually have to do that, find out what that is. So now on the top here, I'm going to be left with x squared plus 1x minus 3x minus 3. And that common denominator is that x minus 3, x plus 3, and x plus 3. All right, so now I'm going to subtract it this time with my, I can sprinkle that 1 or just keep it the same. It's going to be x plus 3 on the top, and on the bottom is going to be that common denominator that I made, x minus 3, x plus 3, and x plus 3. Okay, so now I can just go through and actually do this. So I'm going to change this into a plus and change both of these to the opposite. Okay, that's what we've been talking about for a while, since the beginning of the year. So now if I look, my x squared, that can't combine with anything. So I have x squared on the top, and I have 1x minus 3x is going to be negative 2x, and then I have plus that negative x over here. So that's going to be negative 3x. And I have this negative 3, and I have this negative 3 over here, so that's going to make negative 6. All right, and then my bottom is still that x minus 3, x plus 3, and x plus 3. All right, so that one there, we had to create those like denominators there. So most of the time what you're going to see on your homework is that whatever's over here, you pretty much just have to multiply that to over here to get those common denominators. So pretty much multiply what's ever on the other side to the other side, and what's ever on the right side to the left side to get those common denominators. There we had that 1x plus 3 that was in common that we didn't have to multiply. Most of the time though, you have to multiply by those guys. All right, so big thing there is that you have to create those common denominators before you move on there. Create those common denominators, then you can add the tops and the bottoms. All right, so moving on, we have complex fractions here. What I want you to know for a complex fraction is that a complex fraction is a fraction within a fraction. All right, so here, if you look at example number 4, we have a fraction on the top, and we have a fraction on the bottom. So it's one big fraction with a couple fractions inside it. So what we pretty much have here is, if I can rewrite this, it's going to be 2x over x plus 3. Whoa, I don't know what happened there. We have 2x over x plus 3. And we're going to divide that with 5x squared over x minus 2. All right, so if I look at that, we talked about problems like this the other day in class, is that instead of multiplication, what do I like to do? You're exactly right. I like to multiply. So I'm gonna instead of division, I'm gonna multiply, by the reciprocal. Okay, so keep this one, switch this to multiplication and flip that. So that is what I'm going to do. So I have 2x over x plus 3 multiplied with x minus 2 all over 5x squared. Okay, so now to figure this guy out here, I'm just going to cross out some like terms on the top and the bottom. So I can see that I have an x on the top and I have an x on the bottom, so I'm left with just 5x on the bottom. So what I'm left with here is x minus 2 on the top, and on the bottom I have 5x and x plus 3. All right, and at that point, can't simplify anymore, so that's perfect. All right. Awesome, awesome, awesome. So there, instead of dividing, I like to multiply by the reciprocal. So really nothing new there. We've seen problems like that. It's just an example like number 5 that's going to get a little bit difficult. Okay, so in number 5, I kind of have two problems within one here. So it asks me here to divide 3 over x minus 4 by this whole expression on the bottom right here. So I'm going to take that whole expression right there, and I actually have to add it first. So I'm going to look is that if I have, I'm just going to rewrite this guy here. I have 1 over x minus 4, and I'm going to add it with 3 over x plus 1. Okay, in order to add those guys, what do I need? If I go back up here, in order to add things, I need to make these common denominators here. So I look, find a common denominator. My common denominator between x minus 4 and this x plus 1 is going to be x minus 4 and x plus 1. So I can just multiply those guys together to get my common denominator. So I'm going to write that twice here to get my common denominator, x minus 4 and x plus 1. So then I have to multiply that x minus 4 by x plus 1 to get that common denominator. So I got to multiply the top by x plus 1. So I have to multiply this side by x minus 4 and multiply that 3 by x minus 4. Okay, so now if I go through here and solve this, I can sprinkle that 1 onto both those, so I'm left with x plus 1 on the top, and over here on the top, I have 3x minus 12. All right, so if I go through here and actually solve this one, I'm going to change this into addition, make these the opposite of what they actually are here. Okay. Oh, excuse me. This is addition in the actual problem. So I'm going to make these guys back to what they started with here. So that's my bad. It is addition. I wrote minus. All right. So now we have here combining these like terms on the top. Since we have common denominators, we have x plus 3x is going to be 4x on the top. All right. And 1 plus a negative 12 is going to be negative 11 on the top. And on the bottom is going to be that x minus 4 and x plus 1. So that's a little bit of preliminary work there, is that this whole thing that I circled here turns into this. All right, so now I'm going to write this guy out by saying that I have 3 over x minus 4, and I'm going to divide that with 4x minus 11 all over that x minus 4 and x plus 1. All right, so instead of dividing, what do we like to do? Keep, switch, flip. I better hear that from you. Keep, switch, flip. So now I keep the first one. I have 3 over x minus 4. I'm going to multiply that by that x minus 4, x plus 1, all over that 4x minus 11. All right, so now if I'm multiplying here, I can look to cancel these guys out. So here I can see that my x minus 4's cancel out. So I'm left with that 3x plus 1 all over 4x minus 11. All right, awesome. Great. So there, what I did there is I combined these guys. I added these guys that were on the bottom here. I added those guys to make this over here, and then I put that keep, switch, flip, and I actually found out what that was. All right, so again, just to kind of recap here, when we are adding and subtracting rational expressions, make sure that you create those common denominators. So like in this example here, I had 3 on the bottom and I had 5 on the bottom. So my common denominator is when I took those two guys and I actually just multiplied them by the opposite. So I multiplied 3 by 5 and I multiplied the 5 by the 3 there. Okay, so most of the time getting those common denominators, you can just multiply by what's on the other side for that denominator. All right, so that is all I have for the 9.5 notes. Now it is your turn to show me that on the 9.5 worksheet. So please take a second, work on the worksheet as groups in your pods, see what you can do there. The first couple on that 9.5 worksheet do already have common denominators, so you can just worry about adding the numerators there. So again, the other ones, you will have to create common denominators there. So try that skill. Make sure whatever you multiply by the bottom, you multiply by the top. So when I come back, we'll talk about these guys, see how they work. Thank you for listening, and make sure to subscribe.